Hello, internet friends. It's your boy Cakes. My latest hobby is embedded systems investigative journalism, and I decided I wanted to make some YouTube videos, mostly because I have a terrible memory and I want to remember what I did, but also because maybe some of you other nerds out there want to learn along with me. What you see on your screen is the insides of a ZTE brand home fiber optic modem router thing. The model is F688. It looks suspiciously like my home router, but taking that apart would be dumb. So this particular one I bought off the interweb for about 20 bucks, and it looked like this when I first got it. So our next step after breaking this thing open is take a look at the components on the board. See if there's anything interesting, get some data sheets. So this is the CPU, obviously covered by a heatsink. This is probably the RAM. And right here is a NAND flash. So picture of that is right here. Winbond 25N, blah, 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 blah. Google that. And we get the data sheet. The TLDR on this thing is it's 128 megs of flash, NAND flash, basically the hard drive. Cool. So that's holding all the data with the software for the router. And then the other cool thing that we found is this UART serial debug port, which is what I'm going to explore next by plugging into it with this thing right here is upside down FTDI 232 cheapo USB to serial. Now there's about a bajillion videos on YouTube about how UART works and how to connect to it, so I'm not gonna go into that. You can just watch one of those, but it'll probably be easier to understand after I do it. So let's connect up this thing. Now we're in a Linux virtual machine that I set up just for making a video about this. And we have this USB to serial device forwarded into our virtual machine so we can use it. And we're going to connect with PicoCom. Okay, and we're ready to go. So we're going to power this sucker on and see what happens. Hit any key to stop auto boot. Might want to check that out in the future. So now we just have a Linux boot log, and we're recording it all to a file so we can read it later. And here we have a Linux login. So we're going to try a few logins, see if we can get in. Root. New. Okay, I tried a bunch of passwords. Nothing worked. So we might have another go at that login prompt later. But what I really want to do is look at that boot menu. So let's get out of here. Reboot this sucker. Any key to stop auto boot? Hi. Okay. Help. So this looks like a boot menu. Cool. Lots of interesting stuff to look at. And I've already been through all this stuff. So basically what I want to do now is dump the firmware off of that NAND flash. And there's a few ways I can do it. One way would be to connect directly to this really tiny NAND chip and directly read the data off of there, which would be annoying, especially because it's really, really small. Let me see. Let me show you a picture of it. Yeah, so we have this picture of it. I mean, this thing is really, really tiny. There's a picture of it with this pen next to it. I mean, I'm terrible at soldering, so this would be rough. Connecting leads to that thing. So I'm gonna try to not do that. There might be some way to transfer the files off of here, but at least in this boot menu anyway, there's some FTP commands. They can only download stuff, so I guess they're used for updating the firmware and things like that, but I couldn't find some way to transfer the data off. What I did find was a couple commands that we could use. The first one is NAND. Okay, so the NAND subsystem. So this can read data off of the chip. So let's see, NAND dump page, NAND dump, help NAND dump. Okay, and dump page. So page 0. Cool. Okay, so this gives us a hex dump of the first page. NAND flash is broken up into pages. This particular one is, according to the data sheet, has page sizes of 2 kilobytes. Cool. So when you read the data off of the NAND flash, you can only read them one page at a time. This one has 2 kilobyte page size, so this can potentially show us all the data that's on the chip. Let's see, NAND dump 1. Okay, it wants an offset, not a page number. NAND dump 800. Okay, so that's page 2. Cool. So what we could potentially do is make a script to dump out each page one by one off of the NAND chip and dump it, reassemble it into a binary file, which is what I did. So I wrote this Python script that basically connects to that same device we were using to talk to the router over UART and run that same command for every single page and parse through all the data and dump it into a file. And here's how it works. So it sits there and it waits for the router to boot. So we're gonna reboot. And then once it sees it, it goes into that same menu and it starts dumping it one page at a time into a file. Now, unfortunately, UART is super slow, and this takes about something like 11 hours to dump the whole 128 megs, but I did it. Now, after dumping the whole 128 megs of flash over 11 hours, we can take a look at it with binwalk. And it tells us that there's some file system stuff in there, but this ended up being a little misleading. It wasn't reading it properly. And the reason is it wasn't split up into its component parts. Like when the router boots it, it splits the data that's on the NAND up into a bunch of partitions. Now, luckily we recorded that boot log. So if we take a look at that, in this section right here, it tells us all the partitions that it splits it into. So What I did was I made a script to extract all those into their own separate binaries. So if we run that, it extracts it all out and we have a bunch of these different binaries, and we can use binwalk to look at them individually. And this one ended up being the actual root file system for the machine. There's a bunch with a bunch of different stuff on them, and I dug into all of them, and this one ended up being the one that I want. So we extract that with binwalk -e. Now, while this is extracting, it's worth noting that it's using the JFFS2 file system, which is specifically for NAND flash chips. We'll take a little bit more of a deep dive into that later, but let's see what's in this root file system. Now, what I'm really interested in is getting root on this router. So one way that we could do that is if we knew the login password to that terminal that we found earlier. So we can do cat let's see, shadow, and we can see here that there is a root user and this is the password hash. So what I did was I threw that into hashcat to try to crack the password, and I used some pretty big word lists and a few days worth of brute forcing and couldn't get a hold of the password, so that's out. So my next idea is, if I can't crack the root password, maybe there is some way that I can write a new shadow file with my own password back onto the NAND flash. Now, unfortunately, in this boot menu, yeah, we can read some data off of the chip, and that's what I did to extract the firmware. But there wasn't a good way for me to write specific data back onto the chip easily. It didn't seem like yeah, you can write stuff, but you have to load the data into memory first somehow. That idea didn't seem good. So somehow we have to interface directly with this little tiny chip, and I don't want to do any soldering, and I don't want to take the chip off of the board in order to do the reading and writing. So I think we're going to end this video here, and in the next one, we're going to figure out how we can talk to this NAND flash chip and potentially write some data without taking the chip off of the board entirely and without doing any soldering. Anyway, hey, thanks for watching the video. Please drop me a comment, tell me what you think. Click subscribe if you want to see more, and I'll see you in the next one.